guess we're good. All right. I guess we're ready to go. Thanks, everybody, for showing up. Certainly fully aware that we are the last presentation before the keynote, and everybody is ready to get out of here. So I appreciate you bearing with us as we get through this. I'm sure there will be a major rush to make sure that everybody's seen for the geos that are closing out everything. So thanks again for showing up. My name is Mike Saxon, principal engineer at Booz Allen, joined today by JC Sullivan, who's one of our lead engineers at the firm. And we're going to talk about rethinking sensor collection strategies. When we saw the abstract come out, we saw a lot around how do you centralize sensor data to make decisions in the battle space for situational awareness. JC and I have both worked in the cyberspace for many years now, and one of the challenges as incident responders and threat hunters that we found is the size and scale of the DoD, and specifically the Army, is incredibly challenging to get real-time insights because there's so much data. As we start traversing out, it becomes even more difficult due to some of the different characteristics. So we're going to walk through that today. But before we do, I'm going to let JC start and just kind of walk through the slide a little bit and talk about the battle space and how sensors are deployed and the ability to collect and analyze that data.
Yeah, thank you, Mike, and thank you guys for joining us. What you have here is our version of the JADC2 horror graphic that some of you guys might be familiar with, the challenge of doing command and control out in a forward-deployed environment where you have innumerable operational profiles, different sensor types, and in theory, you should be able to integrate this across one cohesive command and control structure, and more specifically than that, one technical interface, the platonic single frame of glass. What we want to talk about, I think, a little bit more than just situational awareness, I've had it explained to me really well that command and control is both situational awareness and battle management. And so sometimes I get concerned when we talk about sensor integration, specifically in an environment like this where you're going to be going across multiple domains, that the battle management side of the house gets neglected. And we start to think about exclusively building out situational awareness platforms. And that's all well and good. You need to have situational awareness to make smart decisions, and you need to be pulling in accurate real-time data from a number of sensors. But we're building, I think, a chasm between situational awareness and battle management in such a way that if we don't think critically about it, we're going to give our commanders a front row, really high resolution 3D movie of a battle space that they can't actually control and conduct effects both defensively and offensively. And so one of the things that we think a lot about when trying to address this problem is thinking above and beyond situational awareness and pairing situational awareness generated from a multiplicity of sensors into a framework that you can actually maintain technical control over the sensor structure. And with that, I will turn it over to Mike.
Thanks, JC. So we've summarized the problem statement here really into three key components. Big challenge out there is coalition and partner networks introduce complexity when we start talking about multi-enclave, multiple different storage areas. The DDIL environments are incredibly difficult to collect data from and provide situational awareness and battle space pictures. As you start talking about system resources, overhead requirements, and the given space and type of conditions that exist in multiple different levels across tactical and operational environments. And finally, the introduction of the Internet of Battlefield Things, IOBT, creates more data. It's already very difficult to get and move data to centralized locations now. Expanding the footprint with more devices is going to make it more difficult. And so as we started looking through this, I kind of went back to some old experiences that we've had. So about 3 years ago, I was the deputy program manager running the R Cyber 8 COIC back when it was at Fort Belvoir. And one of our biggest challenges was getting real-time insight into what was actually going on across the Army's network. We had great, generally historical knowledge, but the challenge that we kept running into is that environment pipes coming from Hawaii, the pipes coming from Kuwait, European theater created an issue with just moving the amounts of data from one location to another. And then we had CONUS, which was just so big, it was a volume of data pushing through the pipes. that ultimately it created some challenges with really understanding the business logic, or I'm sorry, the overall key performance indicators that we were trying to do as an organization. So we started looking across the industry about how do these large-scale commercial organizations do these run their mission when they have data in multiple different locations and get the business logic out of it. The area that we found was really the closest was Uber, and that is because they have a very innate business sense tied to the way they build their engineering. As many of you know, probably catching an Uber here sometimes recently, surge pricing goes up on demand. They were having almost a 4-hour delay before they built their new architecture because they weren't able to get the insight to drive surge pricing, which ultimately meant that they weren't bringing in the revenue that they needed. They introduced this model, and at the end I have a code that you can go to and check out all the links and the articles on all of this, but they introduced a look at distributing your detection and your analysis across their network, storing it in multiple different locations so that you're not needing to bring everything back to one location. And that's an approach that we took across multiple of our many of our clients in the federal space now, because these networks are so large. The Army's 1.2, 1.5 million endpoints. It's difficult to get that telemetry data back to a central location. But in these two use cases, we found a couple things. Centralized storage brings overhead costs that reduce visibility over time. It's incredibly hard to centralize data and have an effective way to analyze it to make real-time decisions. Decisions that inform real-time business must be parsed from other data. From the cyber side, if you're looking at a root-level intrusion, you want to know about that really fast. If you're looking at how to drive surge and profit, you want to know about that really fast. And then finally, scaling smaller systems happens much faster than scaling large systems. A lot of these really big architectures are complex to manage, and when you need to make changes on the fly, it has an overall situational impact in the performance of the system. A few years later, Google released a great book. Again, the link's at the end. It's free online, Site Reliability Engineering, How Google Runs Production Systems. You can read a lot more about it there if you're interested and how to look at these distributed architectures. But ultimately, it came down really to 4 key components. The first one is when you're starting to look at multi-sensor environments, instead of trying to centralize the data, start thinking about it from a data... I'm always shy to say data-driven approach because I think that's overused, but start looking at it from how data defines your business. Push the data where you need to understand it down to the closest place in the edge possible, and have that be things that you write alerts on and capabilities on so that it comes back to you and you have direct access to that key information. Finally, the other one was, or another one was route data based on required situational awareness, and that's where we talked about sending the detection or the business logic searches down to the edge. Do that through a series of chains instead of trying to bring it all back and crunch through terabytes and petabytes of data, because that is going to have an overall delay. As you start looking at bringing in more data, there's more latency in the network, there's more data to crunch through. You start looking at really big data sets, it's just easier to split it down into smaller levels and chain it up so that when the commander needs that situational awareness, only the data they need is present in that dashboard or that COP, and they can have the immediate impact that they need. I kind of covered on the third one, push query analysis to the edge, but we like to say take detection to the data, not data to the detection from strictly a cyber sense, and that's the ability to federate your networks and do distributed computing, edge computing out at the closer edge to the tactical environment. And finally, as you start looking at multi-enclave, multiple classification networks, getting large amounts of data, not just compressed, sent, landed, decompressed, scanned, through a cross-domain solution, compressed, and then sent and stored where it needs to be, and then indexed is an incredibly long path. Instead of looking at sending petabytes of data, start looking at sending just the queries that you ask to return the results back for, and let that come through the cross-domain diodes instead of trying to send all the other information through. So these are just some of the key tenets. I'm happy to talk more in technical detail about a lot of this stuff, but we didn't want to get too in-depth for here, just given the short time frame, because we know everybody's anxious to head to what's next and go home. But we'll close it up with JC just talking about how we put this into action some places, and then we'll talk questions or comments afterwards.
Yeah, thanks, Mike. So what we're showing here is our Cyber Precog Flyaway Kit. This is a flyaway kit that we've been developing in partnership with NVIDIA, who provides GPUs. You can see the blue field up there because I like to mine crypto in my free time when I'm not working, and then an NVIDIA A100 for data center processing. The form factor, which you see there, is actually made by Ceiling Tech. They are literally right on the other side of this wall, if they haven't already gone to happy hour or headed home. But to go back to kind of the principles that Mike was talking about, we were born out of the DDIL space, disconnected, degraded, intermittent latency environments. So all of the, let's say, crutches that you might use to solve this problem with data lakes, cloud-enabled infrastructure, web-based querying from data stores, none of that is available to us. So we had to learn these lessons in real time with actually no safety net with those, large data stores that you could normally rely on. So when you talk about things like routing data based on required situational awareness, for us that was a literal engineering requirement, meaning that we could not port and process that much data on an edge system without doing some situational awareness requirements gathering around the way the data is going to be used. Same thing about conducting data analysis and detection at the edge. So oftentimes the folks we work with are forward deployed operators who are used to sending their data back to some HQ, insert some agency that they work with, to conduct their detection, analysis, and often return them with some directive or do-out. Our operator said their dream case would be if they could actually conduct that analysis at the edge on their own systems without having the HQ requirement. That helps, one, in terms of accelerating decisions. It also helps when you're dealing with an adversary who might be deploying an A2AD strategy, where, again, those reliances on reachback support might no longer be valid. And fourth, looking at developing out cross-domain solution sets. For us, again, scale is the name of the game, and the more that we can distinguish and discriminate in terms of breaking it down to the most important parts, both in terms of the data we ingest and then what we outbound to other sensor collection points, that's going to be the difference between mission success and mission failure. So in order to facilitate this process, hardware is great, but hardware by itself just sits and takes up space in your server rooms. We built out a software paradigm called Cyber Precog. Cyber Precog is a software platform that is designed first and foremost to take advantage of the GPU technology. So GPU accelerating workloads that are mission critical, and so when you get those strenuous edge sensor collection requirements, you can actually execute them according to whatever analytic paradigm you want to deploy versus having to make trade-off decisions about how you handle that data. But then second, and probably more important to this talk, is orchestration of data and integration of sensor inputs with other sensor inputs that we're drawing from across the battle space. And so, as Mike said, happy to talk about that in more detail, the specific software and hardware design decisions that we're making to help enable operators working in this mission space. But I will stop there and turn it back over to Mike.
Thanks, JC. Give a shout out for AFCEA. There's an email that you might have all received about a talk coming up. I think it's the 25th of this month. It's talking about deploying containers down into the edge. Give you a little bit of engineering background. A lot of the stuff that JC and I have been talking about is taking those containerized microservice environments, pushing them out closer to the edge and relying on that. So if you get a chance, if you got the email, it's definitely worth checking out. I mentioned there's a reading list. I promise the QR code is safe. It's not going to take you anywhere. It's going to take you to a list where you can click on a couple of these different links. As far as the Uber article we talked about, the Google Site Reliability Engineering article, we released some open source code at ShmooCon, which is a cybersecurity conference earlier this year, that really gets after that approach, doing threat detection, cybersecurity detection in a containerized environment. The entire engine is able to process 40,000 events per second, and it averages out about 15 megabytes worth of a capability. So think about spanning that across multiple different places really starts to get to what we're pushing with taking all this down to the edge. And then finally, the last piece was just on the article is the link to the Signal containers at the edge talk as well. So I'll open there, see if there's any questions or comments from anybody in the group. Otherwise, we'll let you all get upstairs. Chief. Yeah. So I think one of the things JC was talking about is, the trade-offs, right? And these are all things that we have to think about. So typically when we talk about sensors, we're talking about having it be a second chain in the collection process. So what we would embed those sensors in is already going to be infrastructure that exists. Maybe it's your server stack that's on your TAC LAN that's in your tactical environment. Instead of having that as a consolidation point and then a push to a central location, we would enable all the analysis to be done in that environment. So the signature profile is fairly in line with what would exist just to conduct operations to begin with. But thanks for the question. Anybody else? Awesome. Enjoy the rest of your week and your weekend.
Thanks, guys.